from listening to you talk about that, I think that for teaching, we probably are all going to have to get a little bit more data literate, and that's going to require some numeracy because, like you said, the evidence is really convincing about some ways that we should try and change our teaching perhaps. But knowing which evidence and what's the convincing bits, it takes a level of numeracy that maybe some of us are not quite.
I think there's still elements that we're learning as well. Like, I think there's still elements that we're learning about, like, how the kids respond to various teaching styles and things. Kids can be very resistant to, Eddie mentioned growth mindset and not having a fixed mindset about their ability, but making that change, identifying that growth mindset is possible and that you can train it in your kids is fantastic. Finding the right way to do it with the kids that you have, like, they often come to us after 6 or 7 years having not thought like that, and that's not to put it on primary school teachers by any means, but you know, it doesn't take much for the child to think that they are good or bad at maths. It can simply be when, like, my son's just learned how to count. He's 4 years old and starts counting with his finger and things. He counts 8 and it's actually 9. I correct him, and I might have just created that in him that, you know what, okay, I was wrong. What was important was that I got it right. Not that I knew how to count, that I got it right. And so therefore I'm bad because I was wrong. And that, I think I have corrected him on at least one occasion, and I've certainly tried to stop myself from correcting him on at least one occasion. But again, I don't know whether that's necessarily the important tipping point for him. I think my point is just that it can be any number of things, and by the time we get them in high school in particular, not necessarily through their primary school teaching, but just through the fact that they've been experiencing maths for 6 or 7 years, successfully or unsuccessfully, again, completely defined by them whether they were successful or not. They might have got the right answer but been very slow, so bang, I'm not as smart as the other kid. Those kind of things, getting them to change that mindset is not necessarily an easy thing. And so whether or not we have the evidence around that, like, we've got a lot of great things. It makes it an exciting time, and as we've talked about, it makes it a challenging time as well, because I think we're all still getting that research, putting it in our classrooms, and then succeeding and failing and working out where we go. Yeah.
Can we try and draw together a few things that you've been talking about? Because we've been talking about some of the challenges and struggles in mathematics specifically, but at the same time, all of these wonderful things about being a teacher. So I was wondering, could you try and describe for us some of the things that you think would be great to try, in a way, things you wish you'd known when you started teaching, about things you could do in your classroom that you'd like to encourage other people to maybe give a go to sort of bring maths alive and make it something where our students feel like they're excited, they're curious, they're eager, and that maybe even that becoming a maths teacher's for them, that it's that good to be in a maths classroom. And I wanted to try and do that by just using some of the words you talked about already. So you've talked about flexibility and autonomy. You've talked about exploration and taking risks and being confident. And if I just go with those words to begin with, what does that look like in Year 7? Or what does it look like in Year 9? Can you tell us about some lessons you've tried that have been okay? We won't say they worked, because I think that whole what works thing can sometimes turn people off, but things that work that the students seem to like and you think they learned something really worthwhile from.
I think as Dylan William likes to say, you know, everything works somewhere and nothing works everywhere. So the important thing is to ask, well, under what circumstances does it work? Which means you need to try a diverse range of things. I think probably one of the things that comes to my mind immediately is we've been talking in the Stage 6 syllabuses about, for the first time, we've mandated what the school-based assessments, what form those are going to take, and the idea of using investigative type assignments and tasks and research tasks in mathematics, which is making a lot of people nervous, but for me just sounds like an opportunity. We talk about the importance of connecting students' learning in all areas, not just mathematics, but especially mathematics, connecting their learning to their own context and showing the relevance of that. Now, I'm convinced a lot of what we try to do in making learning relevant isn't real world learning. It's what Dan Meyer loves to call fake world learning. It's, David was buying 47 watermelons at a cost of foot, and it's like, that's not what, I mean, watermelons, cucumbers, whatever food you want to eat. It's that's not really something people would do in the real world, and they certainly wouldn't try to solve a problem like that by forming a set of simultaneous equations. So it ends up being a very contrived an artificial application of mathematics. What I think might be a good place to begin, and I've seen this happen at my school and a lot of other contexts around, is to say, well, let's find a local issue, a local problem, something that's pressing on you. This comes to that purpose idea before. Like, why am I doing this? Why am I doing these 50 exercises in my textbook? The purpose is to develop a skill to be able to solve a problem that matters to me. So why don't we start there? And you know what? I mean, for example, we were doing this project at our school a few years ago where we were redesigning, re-landscaping part of the school playground. And that's because it's their environment. They feel very strongly to it. They feel tied to it. And suddenly they are trying to solve problems like, for example, how much would it cost if we were going to cover this entire area in AstroTurf because the grass can't grow there? Well, we need to be able to know its area. Well, it's a weird, wonky-looking shape. It's not a rectangle. It's not a circle. We need to find a way to do this. And suddenly they now have a context and a motivation intrinsically to say, all right, well, let's cover the area of composite shapes. They came up with that. And now we have a reason to go for it. And so I think whenever we can, coming up with a problem, letting students be the ones to pose, this is the context in which we want to apply mathematics. And then for us as teachers to say, okay, well, I'm the one who has the content knowledge to tell you, to point you in a helpful direction for you to start growing, to be able to solve those problems. That's a really powerful instrument to use.